going to jump into this example. Here we have a two-way table. Okay, so we're talking about students here from these colleges and whether or not they were accepted into UC Davis. All right, so let's talk about how to read this table. What does this 6 mean? This 6 means that there are 6 students who are from Sierra College, and at the same time they were accepted into UC Davis. What about this 2? This 2 means that there's 2 students, and what's special about these two students? They're from CRC, and at the same time they were waitlisted at UC Davis. Okay? All right, let's talk about calculating some probabilities from this. So part A says, if one student is selected, find a probability that the student was denied. I'm going to use some notation here. So I'm looking for the probability of getting a student who was denied. Okay, it's going to be a fraction. The bottom is going to be, what are all the possible students I could have picked? How many possible students could I have picked? Well, that's just going to be how many total students do I have, right? What's the total here? So 11 plus 3 plus 2 plus 7 plus 6 plus 3 plus 6 plus 2 plus 0. That's 40. All right, so we have 40 total students represented by this table. And that's going to be how many possible students could I have picked. So that's going to be the bottom number. And then for the top number, how many students were denied? Well, these 3 were denied, these 6, and these 2. So in total, 3 plus 6 plus 2, it's 11. So 11 students were denied in total. Part B, if one student was selected, find a probability that the student was not from Delta College. Here we're looking for a probability that they're not from Delta, so not Delta. Bottom is going to be everybody, so it's going to be 40. And then how many students are not from Delta? Not Delta would be this first row and the third row. Okay, so first row and third row, so that's 11 plus 3 plus 2 plus 6 plus 2 plus 0. And that's 24. Part C, if one student is selected, find a probability that the student was from CRC and was denied. Okay, so this comes to the point of this lecture. So we're going to talk about the difference between the word and the word or. So the word or we'll talk about in the next, and part D. So we're looking for probability of CRC and denied. So in statistics, the word and means something very specific. Okay, the bottom is still going to be everybody, so it'll be 40. Now, what am I looking for here? So I'm looking for the students who, the word and in statistics means I want students who satisfy both of these requirements at the same time. Okay, so what students are both from CRC and at the same time they were denied? So I want both requirements at the same time. So CRC and at the same time denied. It'll be just these 3, right? So these are 3 students who are from CRC and at the same time they were denied. So just 3. Right, so just as a hint, right, the word and means they have to satisfy both requirements at the same time, which means in this table, it's going to be a single number. So it'll be one of those boxes. Part D, if one student is selected, find a probability that the student was from Delta or was accepted. So here we're talking about the word or. So I want Delta or accepted. The bottom is still going to be the same, everybody, which is 40. And then the word or. So the word or means that I'm looking for people who satisfy one or more of these requirements. So you don't have to satisfy both. You just have to satisfy one or more. Okay? So which people would satisfy Delta or accepted? So I don't have to satisfy both requirements. just one of them or both of them if I want. So all of these delta numbers would work, right? Because they satisfy the first requirement. And then also all of the accepted numbers would work because they would satisfy the second requirement. Okay? They don't have to satisfy both requirements at the same time, just one of them. So think of OR as you're taking these two groups and just combining them together, right? You're dumping them together and combining them together. So it would be these numbers, the ones that are checked. So the way I think about it is I take all my delta numbers, whatever the first thing is. I'll take all my delta numbers, which is 7, 6, and 3. And then I'm also going to throw in addition, all of the accepted numbers, which is 11, 7, and 6. Now, the 7 I don't need to include because I already wrote the 7 down when I did the delta numbers, right? So I already included that 7 students already. So I'm not going to include those again. So I'm just going to add on the 11 and the 6. Right? Add those together. So 7 plus 6 plus 3 plus 11 plus 6. And that's 33. Okay. Once again, and because we're requiring them to satisfy both requirements from the table, it's going to end up being one of those boxes. The or, right, we're taking everybody who satisfies this requirement and then also combining it together with all the people who satisfy the second requirement. So you will end up with multiple numbers that you'll add up, okay? And so the way I usually do it is I take all the first requirement numbers and then add on all of the second requirement numbers, being careful not to count anything twice. Right, so being careful not to count the 7 twice. All right, we're not done with example 1 yet. We still have parts E and F, but before I talk about parts E and F, I have to tell you what mutually exclusive means. So 2 events are mutually exclusive if they cannot both happen at the same time. All right, let me draw you a picture to illustrate this. All right, here's event A, here's event B. So notice that if you're in A, you're not in B. If you're in B, you're not in A. So you can't be in both circles at the same time. So this is a representation of mutually exclusive. Okay, so it's sometimes called disjoint because this is a picture of 2 disjoint circles. So what's a representation of the opposite of that? So the opposite of that, so not mutually exclusive, would be a picture like this. So notice that if you're in this region in the middle here, you're in both circles at the same time, right? So you're both in circle A and also in circle B if you're in this middle area. Okay, so this would be not mutually exclusive. Okay, so let me actually write out here because this is kind of confusing to me. So mutually exclusive means cannot both happen at the same time. Okay, not mutually exclusive means that they can happen at the same time. Okay, let's talk about some examples here. So first example, so here's two events. First event, you get in a car accident today. Second event, your washing machine breaks down today. So can those two things happen at the same time? Can you both get in a car accident and have your washing machine break down today? Yeah, they can both happen at the same time, right? So if they can happen at the same time, then it's not mutually exclusive. So this would be not mutually exclusive. Second example, a vehicle has four wheels. A vehicle is a motorcycle. So can you have a vehicle that both has four wheels and at the same time is a motorcycle? No, right? If a vehicle has four wheels, then it's definitely not a motorcycle because a motorcycle has two wheels. So these can't both happen at the same time. So if you cannot happen at the same time, then you're mutually exclusive. All right, so we're almost ready to talk about parts E and F. But before I do, let me give you a math definition of mutually exclusive. Okay, so the math definition, the two events A and B are mutually exclusive Okay, so on the front page, we did talk about the word and, right? And the word and meant both of the requirements happening at the same time. So that's exactly what we're talking about here, right? We're talking about the two events, A and B, happening at the same time. And we're saying that they cannot happen at the same time. So if they cannot happen at the same time, what's the probability? So what probability means that they cannot happen at the same, that they cannot happen? 0, right? So we're saying that the probability of both happening at the same time is 0, which means it's never going to happen. So that's the math definition. And that's what we're going to use for parts E and F. The part E says, let A be the event that the student was from Delta College. Let B be the event that the student was denied. Are A and B mutually exclusive? Explain. When I say explain, what I mean is explain using the math definition. Okay, so what that means is you're going to calculate P of A and B, and then you're going to check. You're going to check whether it's 0 or not. Right? If it is 0, then it's mutually exclusive. If it's not 0, then it's not mutually exclusive. So we're going to first calculate P of A and B. Okay, it's always going to be and in this case, A means something and B means something. So A meant delta and B meant denied. So we're actually looking for P of delta and denied. And this we know how to do, right? So this is exactly the same type of question as part C on the front page, where we're looking for probability of something and something, right? The bottom, it's going to be everybody. So everybody in this case was, I think, 40. And then for the top, I want the students who are from Delta and at the same time denied. So remember, when we talk about and, it should be a single number, one of these boxes. So Delta and denied is which box? The 6, right? So 6 will be Delta and at the same time denied. So 6. And then we're just checking whether is this 0 or not. So you can check by dividing on your calculator, but it's pretty obvious that that's definitely not 0. So because it's not 0, your conclusion is that this is not mutually exclusive. So this is not mutually exclusive. Because when we checked P of A and B, we got a number that was not 0. So P of A and B is not 0. Okay, and that's the explanation I want you to write. Part F, let A be the event that the student was waitlisted. Let B be the event that the student was from Sierra. Are A and B mutually exclusive? Okay, so once again, anytime you see mutually exclusive, we're calculating P of A and B. Okay, it's always the and. In this case, A means something and B means something. So A means waitlisted. And B means Sierra. And then we're just going to calculate this probability. So the bottom is going to be everybody, which is 40. And the top, how many students are waitlisted and at the same time Sierra. So the word and should be just a single number. So waitlist and Sierra is which box? Waitlist, Sierra is the 0. And then the question is this 0 or not? You can check on your calculator, 0 divided by 40, or if you just know 0 divided by 40 is 0. Okay, so it is equal to 0, which means it is going to be mutually exclusive. So this is going to be mutually exclusive. Because when we calculated P of A and B, it was 0. Example 2. So the only difference between example 2 and example 1 is in example 1, I gave you a table of numbers. In example 2, I didn't give you the numbers, right? So you actually have to read the problem and figure out what those numbers are. So let's just go through sentence by sentence and try to fill out this table. Researchers asked 80 people to name their favorite mode of transportation. Okay, so that's telling me that there's 80 people total in this table. So it's not going to be one of these boxes, but I do know that the total is 80. Okay, second sentence. Out of the 80 people who were surveyed, right, we already got the 80, 14 people named car as their favorite mode of transportation. Okay, so out of the total, there should be 14 cars. This is telling me that this entire column, these 3 boxes, should add up to 14. All right, so let me make a note of that. 30 people named train. That's telling me that this second column is 30, should add up to 30. And then 36 people named plane as their favorite mode of transportation. That's telling me the third column should add up to 36. Okay. Next sentence. Of the 24 people from San Francisco, okay, that's telling me that there's 24 people from San Francisco. That's telling me that these 3 boxes together should be 24. So this second row should add up to be 24. Okay, so of the 24 people from San Francisco, there were 5 who preferred travel by car. Okay, so these 5, we're talking about the San Francisco people. So these 5 are San Francisco car. So San Francisco car is this box, and we're saying that there's 5. And 9 who prefer travel by train. So we're in the same sentence. So this 9 people are San Francisco train. So 9 people San Francisco train. San Francisco train is this box, and we're saying that there's 9. Okay, next sentence. 3 people from Los Angeles prefer travel by car. Okay, so 3 people LA car. So LA car is this box, and we're saying it's 3. And 12 people from Sacramento prefer travel by plane. So Sacramento plane, which is this box, we're saying it's 12. And then there are 23 people from Los Angeles. So that's saying that the total for the last row, so these 3 boxes together, should be 23. Okay, and that's all the paragraph gives you. And now you have to find the missing numbers. So now this becomes like a little puzzle, a little Sudoku puzzle. All right, so I know the first column adds up to 14. Right now, it's 5 and 3, so that's 8. So the missing number would have to be 6. Right, you can also go, I know 5 plus 3 is 8, and so 14 minus 8 is 6. And then what else can I find? How about this box? Right, so I know this row should add up to 24. Right now it's 5 plus 9, and that's 14. So 24 minus 14 is 10. How about this box next? So this entire column should add up to 36. Right now it's 12 and 10. 12 and 10 is 22. 36 minus 22 is 14. I know the last row should add up to 23. Right now it's 3 and 14, which is 17. So 23 minus 17 is 6. And then finally, for the last box, I know the second column should add up to 30. Right now it's 9 and 6, which is 15. The missing number would have to be 15 to add up to 30. Okay, so we have all the numbers now. So now we can just answer the questions just like in example 1. Part A, if one person is selected, find a probability that the person is from Sacramento. So notation-wise, we're looking for probability Sacramento. The bottom should be everybody, which in this case is 80. And then how many people are from Sacramento? 6, 15, 12, right? So 6 plus 15 plus 12. It's 33. Part B, if one person is selected, find a probability that the person is from San Francisco or, so here's a keyword or prefers travel by train. So we're looking for San Francisco or train. Okay, bottom's going to be everybody, which is 80. And then remember, the word or means you're going to dump these two groups together. All right, so I'm going to take all my San Francisco numbers, which is 5, 9, and 10. And then in addition, I'm going to combine them with the train numbers, which is 15, 9, and 6. But remember, I counted the 9 already when I counted the San Francisco numbers. So I just need to add on the 15 and the 6. Okay, so on top it's 5 plus 9 plus 10 plus 15 plus 6 is 45. Part C, if one person is selected, find a probability that the person's preferred mode of transportation is not by train. Right, we're looking for not train. Bottom's still going to be 80. Not train would be first column, third column. So 6, 5, 3. And then 12, 10, 14. That's 50. Part D, if one person is selected, find a probability that the person is from Los Angeles and prefers travel by plane. So here, keyword here is and. So we're looking for LA and plane. Okay, bottom is going to be 80. Okay, remember keyword and means I want people who are meet both requirements at the same time. So people who are from LA and at the same time plane. It should be just a single number. So LA plane, 14. And then part E, let A be the event that the person prefers travel by car. Let B be the event that the person is from Sacramento. Are A and B mutually exclusive? Right, so anytime I'm asking about mutually exclusive, you should be calculating the and. Right, so I need to calculate P of A and B. And in this case, A meant car, and then B meant Sacramento. And then you're just going to calculate, right? Just like we did in part D here, right? We calculated and. So the bottom is going to be 80, which is everybody. So car and Sac. So and it should just be a single number. So car, Sac. 6. And then to answer the question, right, we're checking whether or not it's 0. Right, we're checking whether or not it's 0. If it's 0, it's mutually exclusive. If it's not 0, it's not mutually exclusive. 6 out of 80, definitely not 0. Okay, so our conclusion is that it's not mutually exclusive. Because when we calculated the and, it was not 0. Okay, and that's what I went by an explanation. The addition rule. So the addition rule basically just is a formula that tells you how to find the probability of A or B. Okay, and it says to find the probability of A or B, take the probability of A plus the probability of B. Okay, this is where the name addition rule comes from. And then subtract the probability of A and B. Now, let's go back to example 1. So in example 1, we already did probability of A or B, right? And we did it without using a formula at all. So when you have a table of numbers, my recommendation is do the or the same way we did it in example 1 and example 2, right? Don't use the formula. The formula is not useful in that case. But let me tell you where the formula comes from. Right? The formula is telling you to find the probability of delta or accepted. It's telling you take the delta numbers, which is the 7, 6, 3, plus take the accepted numbers, which is 11, 7, 6. Okay, notice I said the 7 twice, and then subtract the and number. So delta and accepted would be delta and accepted is the 7. So subtract off the 7. So that subtraction part is really just subtracting off one of those 7s that I counted twice. Okay? But when we actually did it in example 1, right, what did we do? Right? We said, let's take all the delta numbers, which is 7, 6, 3, and then combine with it all of the accepted numbers, but keeping in mind not to count anything twice. And so we just added on the 11 and the 6, and we just didn't add on the 7 twice. So when we did it in example 1 and example 2, we kind of already did this part by not including things twice. Okay? All right. Complement of an event. Okay, so the complement of an event E, which in symbols we're going to use E for a little c at the top, so E complement, is the event where E does not happen. All right, so let me give you an example of this. So say E represents it rains today. The complement would be the event that it does not rain today. Okay, so basically the complement, just add on the word not. So whatever your event is, the complement of that event, just add on the word not, and that's the complement. Rule of complements. Okay, so this is not really saying anything fancy here. So it's saying something that I think you all already know. So let me start off with an example. So if I know, let's say E is rains today, right? So if I know that the probability of it raining today is 30%, can you tell me the probability that it does not rain today, which is E complement? So if you know that that the probability of it raining today is 30%, what's the probability of it not raining? Well, it's going to be the rest of it, right? So 70%. And what math did you do to get 70%? Well, you took 100% minus 30%. Or in decimal form, you took 1 minus 30%. Okay? And that's all the rule of complement says. It says, if you want to find the probability of the complement, you just take 1 minus the probability of the original, or vice versa. If you want the probability of the original, you can do 1 minus the probability of the complement. Okay, so this is just a formula for finding not. But remember, in example 1, we also already did not, right? We did not delta without using any formulas at all. So whenever you have a table of counts, don't use the formulas. Don't use any of these formulas, right? Just do it the same way we did it in example 1 and example 2. So when should you use those formulas? Well, example 4 and example 5. So in these examples, I'm not giving you a table of counts, right? So you have no choice but to use those formulas. Example 4. Let C and D be events such that P of C is 0.25, P of D is 0.4, and P of C or D is 0.55. Find P of C and D. Okay, I'm not giving you a table of counts, so you have no choice but to use the formula, the addition rule. So I'm going to rewrite the addition rule using the letters of the problem here, right? So the problem here is using C's and D's. So I'm going to rewrite replacing A with C and B with D. Okay, so this will be P of C or D equals P of C plus P of D minus P of C and D. So all I did there was I took the original addition rule, which was written with A's and B's, and replaced them with C's and D's, right? So A, replaced it with C's, and B's, replaced it with D's. Okay, so now let me fill in what I know. So I know that P of C is 0.25. So this is saying that this entire piece is 0.25. P of D is 0.4. Okay, this entire piece is 0.4. P of C or D is 0.55. That's saying that this entire piece is 0.55. Okay, so let me fill in the symbol. So that's an equals, that's a plus, minus. Okay, this I don't know, right? I'm actually trying to find it. So let me replace that entire thing with a letter, so because I don't want to keep on rewriting that. So let me replace it with, say, X. And now this becomes an algebra problem. Okay, so I need to find the X, the missing number X. So let me start off by simplifying on the left side and right side first. So left side, I can't do anything, so that's 0.55. Right side, I can actually combine those. So 0.25 plus 0.4. Is 0.65. And then I still have the minus X. Now, I want to get the X by itself, so what should I do to both sides? To get the X by itself, I need to get rid of this 0.65. To get rid of this 0.65, I'm going to subtract. So we're going to subtract 0.65 from both sides. Okay, left side 0.55 minus 0.65. So 0.55 minus 0.65 is negative 0.1. Right side, that's going to cancel out. I'm still left with minus X. So I'm not looking for minus X, right? I'm looking for regular X. So if I know minus X is negative 0.1, then regular X, what's regular X? Positive 0.1. Okay, and that's my answer, right? So X is 0.1, which is what I'm looking for, P of C and D. So P of C and D is 0.1, which is what I'm asking you to find. Okay, part B. Are C and D mutually exclusive? Explain. All right, so what I want, anytime I'm asking for an explanation, is I'm asking you to use the math definition, right? I want you to check the and check whether or not it's 0 or not. All right, so what we're going to do here is we're going to calculate P of C and D. It's always and. Okay, we don't actually have to do anything because we already found it in part A, right? So P of C and D is 0.1. And then the conclusion, right? Is it 0 or not? If it's 0, it's mutually exclusive. If it's not 0, it's not mutually exclusive. So 0.1 is definitely not 0. So our conclusion is it's not mutually exclusive. Because when we calculated P of C and D, it was not 0. Example 5. Let E and F be events such that P of E is 0.28, P of E or F is 0.42, and P of E and F is 0.06. All right, find P of F. Once again, we don't have a table of numbers, so you have no choice but to use the formula. And there's really only one formula to use, and it's the addition rule. So I'm going to rewrite the addition rule using the correct letters for this example. So this example uses E's and F's. So I'm going to rewrite replacing A with E and B with F. All right. So that's going to give me P of E or F is equal to P of E plus P of F minus P of E and F. All right, so that's the addition rule, but just rewritten with the letters E's and F's instead of A's and B's. And then we're going to fill in stuff. Okay, P of E is 0.28. That's telling me this entire piece is 0.28. P of E or F is 0.42. That's telling me this entire piece is 0.42. E and F is 0.06. That's telling me this entire piece is 0.06. Right, let me fill in the rest here. I have an equal sign here, I have a plus here. P of F, I don't know. That's what I'm trying to find. So let me call that a letter, X. I have a minus here. And then we do the same thing. Right, I'm looking for this missing number X. So left side, simplify, it's 0.42. There's nothing to do there. Right side, I can combine the 0.28 minus the 0.06. So 0.28 minus 0.06 is 0.22. So I have 0.22. That's combining the 0.28 minus the 0.06, and then I still have this plus X. And then my job is to get the X by itself. To get rid of the 0.22, subtract both sides by 0.22. Okay, left side 0.42 minus 0.22. 0.42 minus 0.22 is 0.2. On the right side, 0.22 minus 0.22 will cancel each other out, leaving just this X. And that was exactly what I was looking for, right? So P of F is 0.2. And then part B, are E and F mutually exclusive? So anytime I'm asking for mutually exclusive, you should be calculating the and. And what is it here? What is P of E and F? Is it 0.2? No, right? 0.2 is P of F. what is P of E and F? It's actually in the original problem. It's right there, right? It's actually 0.06. And then the conclusion. Is it mutually exclusive or not? Is that 0 or not? Is basically what it's asking. It's not 0, which means it's not mutually exclusive. Because when we looked at P of E and F, it was not 0. Example 6. In a survey of college students, researchers found that 32% of students use Facebook and 88% of students use Instagram. 49% of students use both Facebook and Instagram. Part A, let F be the event that a student uses Facebook, and let I be the event that a student uses Instagram. Summarize in symbols the probabilities described above. What I'm asking you to do here is write things that look like what we did in example 4, right? P of C equals something, P of D equals something, P of C or D equals something, P of E and F equals something, right? I want you to write things that look like that. So here, we're saying F is Facebook, I is Instagram. And then let's go through and translate what this problem is telling me. It says 32% of students use Facebook. So we're saying that the probability of Facebook is 32%. So we're going to convert percents to decimals. So 32% as a decimal is 0.32. Okay, so anytime we're doing calculations, we should convert to decimals. 88% of students use Instagram, so that's telling me that the probability of I is 88%, which is as a decimal is 0.88. And then 49% is going to be this last one, so that's 0.49. Use both Facebook and Instagram. What do I write here? Is it with an or is it with an and? Both Facebook and Instagram. It's going to be an and. So this will be F and I. Okay, so P of F and I is 0.49. And then from here, once you have this, this should be exactly like examples 4 and example 5. So part B, find a probability that a randomly selected student does not use Instagram. So we're looking for not Instagram, or not I. Remember, we've talked about not already, so that's just the complement. So we're looking for a probability of the complement. If I know 88% uses Instagram, what percent does not use Instagram? Right, so the way you do that is just subtract from 1. So it's going to be 1 minus 0.88. Okay, 1 minus 0.88, 0.12. Part C, find a probability that a randomly selected student uses Facebook or Instagram. So what I'm looking for here is probability Facebook or I. Okay, the or both is in parentheses because the word or includes both already in it. So we're looking for P of F or I. We have no choice here but to use the formula, the addition rule. So I'm going to rewrite the formula, replacing A's and B's with whatever letters we're using here. We're using F's and I's. So I'm going to replace the A's with F's and the B's with I's. So I'm going to get P of F or I is equal to P of F plus P of I minus P of F and I. And then let's go through and fill in what we know. I know P of F is 0.32. So this entire thing is 0.32. This entire P of F is 0.32. P of I is 0.88. This entire P of I is 0.88. P of F and I is 0.49. That is this entire thing on the right, P of f and I, is 0.49. And then let's go through and fill in the rest. P of f or I is what I'm looking for, so let me call that x. I have an equals here, I have a plus in the middle here, I have a minus. The x is already by itself, so all I need to do is just simplify the right side here, and I should be done. So 0.32 plus 0.88 minus 0.49, and that's 0.71. And that's the x, and the x represents the f or I, which is what I'm looking for. Part D, determine if the events using Facebook and using Instagram are mutually exclusive. Explain. So anytime I'm asking about mutually exclusive and explain, I'm asking you to check the math definition, right? Which means calculate the P of A and B, and then check whether or not it's 0 or not. So we're going to calculate in this case, we're using F's and I's, so let me rewrite F and I and see what this is. If we look carefully, we already know what F and I is. It's somewhere above. F and I. It's 0.49. And then the conclusion. Is it 0 or not? 0.49 is definitely not 0, so this is not mutually exclusive. Because when we checked F and I, it was not 0. All right, have a great day. See you in the next one.